So my whole goal here is I'm trying to show that this right here is true. That's my goal, is to show that if I take the second derivative of y and subtract 10 times the first derivative plus 9 times y, that I'm going to get 0 here. So I'm going to have to find the first and second derivative of 1, 2, and 3, and then see which ones work when I plug them into that formula. So I'm going to come over here first and do the first derivative of this thing, if it's going to write. There we go. So we got to do chain rule here. So the derivative of sine is cosine, leave the 3x the same, then the derivative of 3x is 3. So the 3 times the 2 gives me 6 cosine 3x. So that would be the first derivative. And if you don't get something, let me know so I can fix it. And then the second derivative, the derivative of that, again, is chain rule. So derivative of cosine is negative sine. And the derivative of 3x is 3. So I got to take 3 times 6 and get 18. And I said negative sine. So it's a negative 18 sine of 3x. So there's the two derivatives of 1. Roman numeral 2, going to do the same thing. I'm going to do the first derivative of it, which is simply itself. And the second derivative is also itself, because the derivative of e to the x is just e to the x, and you leave your coefficient the same. So all three of those are identical. And then c on number 3 is a constant, so that's like a number, like the number 5 or whatever. So when you do a derivative of e to the x, again, it's e to the same thing, but then when you have a number besides just x, you got to do the derivative of 9x, which is 9. So when I do this first derivative of this thing, I'm going to get 9c e to the 9x. And then when I do the derivative again, I got to take it times the derivative of 9x again, which is 9. And 9 times 9 is going to give me 81 CE to the 9x. So now I got to plug these things in up here and see. I'm going to plug them in right here for those 3 variables and see which ones all cancel out to give me 0. So when I come over here to this first problem, I'm going to change the color because I'm going to plug them in here. So second derivative over here is this negative 18 sine 3x. So I've got negative 18 sine 3x. And then it says up here it's minus 10. So I got to take 10 times the first derivative. So my negative 10 times the first derivative, that's going to be a negative. I'm going to write it below it, negative 60, because I've got this 6 right here. So negative 10 times 6 is negative 60 cosine of 3x. And then last, it's plus 9 times y. Well, the y is 2 sine 3x. It's the given Roman numeral 1. So when I take 9 times 2, I get plus 18 sine 3x. And I hope you can see that if I combine the like terms, which are the first and the bottom one, these do cancel out. But that's negative 60, not 0. So this one does not work. Now I'm going to do the same thing to the next one. So the second derivative is this 5e to the x. And then I got to take minus 10 times this first one. So that's minus 50 e to the x. And then up here I got this 9 times the original one. 9 times the original one is 45 e to the x. So the 45 and the 5 give me 50, and 50 minus 50 is 0. So this one works. So number 2 is true. And then for number 3, I'm going to do the same thing. So I've got this, I'm going to write it over here. I got this 81 CE to the 9x, because that's the second derivative. Then I got to take negative 10 times that. And when I do, I'm going to get negative 90 CE to the 9x. Then I got to take 9 times the original part, 9 times this part, which would be positive 9 CE to the 9x. So again, if I take the 81 and the 9, that's 90, and 90 minus 90, because they're all like terms, gives me 0. So this one is also true. So the two that work are, oops, sorry, not that one. Let me undo that. The two that work are 2 and 3. So it's C right here. 2 and 3 work. So I'm trying to find where the second derivative minus 4 times the original y is going to give me 0. So I'm going to come over here and do exactly what I did on number 5. I'm going to do the derivative of all these. So the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. Then I'm going to do the second derivative because I need the second derivative on all these. So that's going to be 2e to the 2x times 2. And the 2 times 2 gives me 4e to the 2x. Now I'm going to come and do the next one. So the derivative of 2e to the 2x is going to be, again, 2e to the 2x times 2, which is 4e to the 2x. And I do the derivative of 4e to the 2x, which is going to end up being 8e to the 2x. Coming over here is a chain rule. So I have to do the derivative of sine first, which is, let me move that over, which is going to be cosine 2x. And then I got to do the derivative of 2x again, which is 2. So I put that 2 in front. And then I'm going to do the derivative of this again. So the 2 stays in front. The derivative of cosine is negative sine. Leave the 2x the same. And then 2 times that derivative of 2x is 2 again. So this would end up being negative 4 sine 2x. And I got chain rule again on d. So the first derivative of d is going to be negative 2 sine 2x. And doing the second derivative of that is going to give me negative 4 cosine 2x. So now I got to plug those second derivatives and take 4 times the given a, b, c, d and see which ones cancel out again, just like the last problem. So I'm going to change color again here, and I'm going to take the second derivative, which is this 4e to the 2x, and then it's minus 4. So I got to take negative 4 times this original thing. So that's going to be minus 4e to the 2x. And I hope you can see those are like terms, and they give me 0. So A works. This next problem, I got my second derivative is 8e to the 2x, and then I got to take negative 4 times this. Negative 4 times 2 is negative 8e to the 2x, and again, those cancel each other out, so B works as well. Then I take my second derivative, 4 sine of 2x, and then I'm going to take negative 4 times this, so that would be negative 4 sine 2x, and again, those cancel out, that's 0, so C works as well. And then my last one, my second derivative is negative 4 cosine 2x. Then I got to take negative 4 times this, and that's going to be negative 4 cosine 2x. That is negative 8 cosine of 2x, which does not cancel out. So only A, B, and C work.